Hey everybody, welcome to another IIT exam problem session. So this is section 1 of last year's problem 2023 advanced physics part. Of course you have like 17 problems or so and you have just 1 hour to do them, so you got to do it really fast. And section 1 is of course especially tricky, but because there is a negative mark, and you have a negative mark, so you got to be careful. It's better not to answer than answer wrong. Okay, so you only answer what you really know. Okay. All right, so I've done I've done problem 1 and problem 2 in another video, and then I'm gonna do problem 3, which problem 3 has to it's just electricity and magnetism, and not actually electric circuit, just electric circuit, and it's a little complicated RC circuit, and it's a question about these. There is a ambiguity in this question, which is kind of a little silly, because you have these answer to these questions depend on the direction of the current in this 1 ohm resistor. 1 ohm resistor, is the current going this way or that way? It doesn't say. It just says 1 ohm current is flowing, and of course you're going to get a different answer depending on which way the current is flowing. So if you assume the current is flowing this way and you work out some of the answers here, and especially a couple of them, it's like you're not getting the right answer somehow. You probably have to redo doing this other way. Okay, so let me show you. It turns out that I was I picked up when I was preparing for this. I was doing it, and I made sure that I can do it both ways. All right, but it just takes your time doing the test, and this is not fair. All right, so let's let me get another sheet of paper and do this out on that. Okay, so let's answer these questions. All right, so you can see before t equals t0, which let's assume that t equal to 0. Okay, t0 equal to 0. There's no loss of generality here. All right, so this circuit is open, so you can see this branch is not even connected to that, so we can just look at this circuit by itself. So this is like t less than t0. Okay, and this is just a regular resistive circuit, right? And it says this current here, I would say let's see, current here is this way. Okay, I'm going to assume that this is 1 amp is that way. It's not, that's the ambiguity in the problem, right? I earlier talked about. So we can just a couple of different ways we can do it. You can just comment this one node here. You can see this all of these will be at 1 potential, right? This side will be at 1 potential. Let's call that A, and then this will be another node. Let's call this B, and then you can see all of this is at 1 potential. Let's call that C, and then we'll call this point D. And so we if you want to, we can just do this guy's, choose this to be IR. So at C you have IR coming in, 1 amp going out, and I1 going out. IR coming in, 1 amp going out. I'll just not write amp, okay, plus I1 going out. That should all up to 0. So that's one equation. So the current is in amp. All right, and then you can just do one loop like this. So you'll have a from A to B, you get a 15 volt up, and you go in the same direction, so you're going to drop minus R times IR, and then you going in the same direction the current, so you're going to drop 1 times 1, 1 times 1, and then you're going opposite, so you're going to pick up. I mean this is picked up, so this is going to be you're going to drop minus 5 volt equal to 0. So this is 2. I should say just 15. Okay, so we still have unknowns here. If I go in here, this loop, let's go this loop this way. Either we got top loop or bottom loop, but this one has only one unknown, so let's do it this way. So from A to over here you have a 5 volt go up, but here I'm going in the opposite, then I'm going to have to add 1 times 1. That's what I was saying, that if you pick a wrong direction or different direction, you're going to get a plus or minus sign here problem. And when I'm going in the same direction, the current through this I1 minus 3 times I1 equal to 0. So you can see here I1 is 2 amp. I1 is 2 amp. Okay, so this, if I know I1, then from there IR minus 1 plus 2 equal to I1 is going this way, so this is minus, not plus. That's what I was. So at C, IR was coming in, I1 1 amp coming out, and I1 coming out. So these guys are negative, this positive. So this is minus 2. So then IR equals to 3 amp. So you can see, very easy to, if you make a mistake somehow or overlook something, you should definitely try to catch up if something's looking off. Okay, so IR, and if I have IR plug in here, I should be able to get so 15 minus 1 minus 5, that's a 9, minus R times 3 equal to 0. So this R equals to 3 ohm. So I've got all of these things that are known in that part, and I can definitely answer question A. So this is A is correct. Okay, the value of the current I1 is 2 amp. That's B is correct. B is correct. All right, so for to answer C or D, they both have to do with what happens after t equal to 0. So there are probably easy way to answer D, because when you say t goes to infinity, the charge on the capacitor is this. So if t goes to infinity, this once the key is closed, this capacitor will be fully charged. So when the capacitor is fully charged, no more current goes through, so there's no voltage drops here. So if I know VC, VA, so if I know VC minus VA, okay, when no current, when IC equal to 0, which is the same situation over here, right? Then at that point, all the voltage dropping across the capacitor, let's call it A, B, C, D, I'm going to call it E. So between E and A, so all of this will be, this is all connected at that point, and no current is going through here. Then at that point, you are going to have Q equal to CV, C minus VA. So if I figure out what is the, in any of this, like over here the amount of current is going is I1, and I1 is 2 amps, so it's like 6 volt. So VC minus VA in this branch was 2 amp over 3 ohm, 6 volt. So this is 6 volt. So C times 6 volt, and C is 2 microfarad. So 2 microfarad times 6 volt, and this will be microcoulomb, so 12 microcoulomb. And so that one actually is, the D is correct too. This just said D is correct. So that's just easy to get. T goes to infinity limit. So the thing that we have to work out is what happens and when it's still charging. So when this is a charging circuit, we'll have to, now there will be different currents in different branches, and that we have to work it out one more time. Okay, so that we need to, what do we need to do is for C we need to find dq dt plus something q equals to something. So this is a charging equation. We need to find these guys, and okay, so there are some really shortcut ways of doing it, and there's some long way of doing it. We can try to do like, suppose I didn't remember anything and I don't want to simplify the circuit based on my much more advanced knowledge of circuit analysis, then I will just go back and look at the circuit one more time. Okay, so let me redraw the circuit. Okay, so I've redrew this circuit, and I'm just going to use equation that we can generate from like this is one node, this is another node, just like do like before, and this is, so this whole thing is A, this whole thing is, let's call it C, this is B, and then this is D, and this is E, and I'll just write the equations. Okay, so one is so one equation will be just so this one equation, the definition of the current and charging relationship, charge accumulating phase, and second equation will be all the balancing. So at C, this current is current I3, so I3 is coming in, I2 is going out from C, I1 is going out, and IC is going out. I just use this everywhere. Okay, on dq dt. Maybe just write down I3 right now. all right. And even IC right now. So basically we are going to try to make use of IC, and then I can just generate loop equations, all right. So maybe generate let's see over here, and let's see this with IC. We can generate with IC and other loop equations. So to try for the top, and I got one loop. So I got a 15 volt minus 3i3. I'm going in the same direction as IC, minus 3IC, and then what do? This will be minus Q over C. This whatever at that time. Note these currents are not the same as the current, so this is t greater than t0 time, and which I'm going to take to be 0. Okay, is 0 because I'm back to A. I started with A and come back to A, and this loop got a 5, go up in 5, but I'm going the opposite direction the current, I assume. Then I'm going to have to add I2, one time I2, and then I'm going in the same direction as 3IC because I'm going to drop here, and then I'm going to drop QT over C. So usually the definition is you're going to positive plate when you draw a current like this. 1, 2, 3, 4, 5, and you can see our we're gonna have 4 equations here. Okay, these 4 equations, and then we just this loop. Then this one is supposed to go in the same way, so going opposite to that, that's 3I1 minus 3IC minus QT over C equal to 0. From these I need to get an equation like that. So there will be, so this equation will look like some IC plus something Q equals something that doesn't have a Q. So these are all known, okay, and from there from IC plus something Q plus, so we have to get this, all right. And let me pause and work this out. Okay, so so I took those these 4 equations. So first I worked with 3, got the I3 in terms of IC, and then I2 in terms of IC, and I1 in terms of IC. So those are these 3, and then I plugged into this. So everything simplifies to this one long equation, and I can simplify further just combining terms, and then I used IC equals to that, and we have this equation, which I can actually solve pretty quickly. Actually, in equations like this, you can see answer will be the ratio of this over this, and then 1 minus, and this is the time constant, so it's going to be like this, and I can write 5 over 18C in terms of microsecond units, inverse units. And so as long as t is in microsecond, so t0 equal to 0 for us, okay, t0 equal to 0 for us. So we get this answer, and 6 times c is that's just 12 microcoulomb, and from there, so writing this equation, Q of t equals to 12 microcoulomb 1 minus e to minus 5 over 36, I think 36 t, and t in microsecond. You can already see that t goes to infinity. We already had the answer. T goes to infinity. Fully charged is just 12 microcoulomb. We already knew before, if you remember from my little open circuit or no current through the through this branch when fully charged, then just is the same answer. The D can be rechecked that way. If a t of some finite number, so the t that we are looking for in this question is 7.2 microseconds. So I put t equals to 7.2 microseconds. 7.2 microseconds, then I'm going to get 5 over 36 times 7.2, which is so if it was 3.6 times 10, then this will be just 2, and 10 to 10 is just 1, and so q of this time is equal to 12 microcoulomb 1 minus e to the power minus 1, e to the power minus 1. And the question actually tells us to use e to the minus 1 is 0.36. So we have a 12 microcoulomb 0.36, and so this just 0.64, and so this is 64 over 100, and you can see 16 and 25. So we just have to check is 0.6 or not, right? This is not what the question. The question is the current in. We're trying to figure out what the Q is, but the question is about the current. So actually, the current is much easier to get. Of course, I can get the Q from here, and then plug into. You get the Q from here and plug into here to get IC, current in the capacitor, right? Current in the capacitor. Question is the current in the capacitor and not the charge in the capacitor. But if I got Q formula like this, then let me bring it over here. IC will be just dq over dt, and then you can see this will come down here. So I'll have a 12 microcoulomb to minus of 5 over 36 e to minus 5 over 36 t, and this whole thing I want to get t equals to 7.2 microseconds. So the previous you can numerical thing you can work out, and so this is minus 12. This minus with other minus becomes a plus 12 times 5 over 36 times e to the minus 1, and so 12 times, so this is 3, and this is 3 point 0. I think that 0.36 is given 0.36, so this makes it 0.12, and that just comes 0.6, and everything is micro and microsecond cancels out, and this becomes an amp. So 1 over microseconds, so this is 1 over microseconds, and this was a microcoulomb, and this micro cancels micro inverse, and the coulomb over a second turns into the amp, which is equal to coulomb over second. This amp just equal to coulomb over second. Okay, so this just answers that. When I go back to that, so this is this also correct, this is correct, this is correct. If I look at this is correct, this is correct. Wow, this is all 4 of them were correct. Okay, this is pretty rare, but all 4 of them are correct. That's a good answer. This is a good problem. It actually tests a whole bunch of different parts, and I gather you can definitely get A and B right away, and A, B, and D, and C might take you a while. It's okay if you didn't get C. Okay, if you do this out, and if even this exam situation, it's best to get A, B, and D, and come back to C later, because this this is going to take you time to work out. And you can see that if all 4 options are correct but only 3 options are chosen, so those are 3 that so you got 4 out of 3 already, of 3 out of 4. So that's actually a good strategy in the exam, and you can come back later to finish the D part, I mean the C part in this question. The ones that you can get easily, just get them right away. Okay, so that's it. So that's the end of the section 1. In other videos, I'm going to try to answer section 2. Bye.